What we're going to get here, guys, is we have a trigonometry question. Okay? BCA. How do I know for certain this is not a geometry question?
That's not.
Simply, there's no coordinates. There's no talk about lines or circles. It's just a triangle. And you're given length, but you're given no coordinates. So it's definitely a trigonometry question. Now, once again, just to really hit the point home. In trigonometry, here are your following options. Pythagoras' theorem, SOHCAHTOA, cosine rule, sine rule. Which two can I eliminate straight away? Pythagoras' theorem can go, and why? Not right, a triangle. So now you're left with sine rule or cosine rule. Now, cosine rule is used in the case of cosine rule, guys. It's pretty easier just to learn off why you do the cosine rule, and if it doesn't fit, then you can just learn the sine rule after that. Cosine rule is side, 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 or sandwich, side and side. Do we have either scenario in this question? Side, side, side. So we're definitely using the cosine rule. Now, the next thing is, what type of question is this? Is it a length question or is it an angle question? It's an angle question. What is the only way an angle question can end? Sine inverse, cos inverse, or tan inverse. You've got to inverse something at the very end. Now, the most common mistake made, when you do an angle question, when you know this is an angle question, you quarantine off this part here the minute you recognise it's an angle question. And that's the last thing that's going to move. It's because of PEMDAS rules. PEMDAS means that it's 2 multiplied by B multiplied by C cos A. They're linked together by multiplication and therefore can only be separated by division on the other side. They cannot be separated. Okay? So what we're going to do is you pick a side, you pick the 12 because you're trying to find out BCA. So by picking 12, you automatically pick the angle that looks at the 12. Does that make sense? The side that you pick, the side that's opposite the angle you want, always goes in as A. The other two sides can go in, they just go into the BC slot. And it's 2 times 8 by 6. Now your cos A, or cos A is cos X in our question, isn't it? Now, the most common mistake people make is this: 36 plus 64, that's 2 times, that's 16 multiplied by 6 minus 96. What a lot of people do wrong is they actually add the 3 of them together. Why does the 96 not do that? It's being multiplied by cos X. It's not 96 on its own, it's been multiplied by the cos X. Therefore, once again, it's alone, it's quarantined for the time being. Add the 64 and the 36, bring it over to the other side and take it away from 144. So 144 minus, wherever, 36 minus 64, 44, yeah? 44 over, 44 over, we don't know yet. So, can I ask you guys a question? We're going to make a prediction, and when you make predictions, it helps you guide your answer. What type of answer do you think we should get for the angle X? Would 20 degrees be a good answer? What? No, just the angle itself, just a rough guideline. Do you think it's a cute angle? Like 10 degrees, 20 degrees? I think it's got to be the biggest angle in the triangle. So it has to be bigger than the other one. So it can't be a 60. It has to be it's more than likely obtuse. So if we don't get an obtuse angle, we've messed up. Now, you can divide by 96, or you could multiply by both sides first, and then divide by 96. Cos X equals minus 44 over 96. I'm going to show you a mistake. Okay? Okay guys, I'm going to cos inverse that, yeah? Somebody do that in the calculator and I'll do it in my calculator, and you tell me what happens to me. Has anybody done it in their calculator yet? Yes. What'd you get, Dennis? Or Nick? Yeah, no worries. 117 degrees. That sounds good, doesn't it? What happened to me?
You're in OR mode, right?
I'm in R mode. Got an answer completely different than what I'm expecting.
That's a little risky though, having an R mode.
No, I did it on purpose because you sometimes walk into their exam in R mode for some reason. The calculator hit off their bag, and they go through the full trigonometry section, giving the wrong answers over and over again. So that's why we're rehearsing this now. Not the answer we're expecting. You see, it's in R mode. R mode is a setup issue. You go to shift, setup, and you go, oh look, R mode must be radians, therefore D mode is degrees, press 3, and then just go back to what you did last time. 117.28. Okay? Well, there's a good thought of that scenario, and we're not going to encounter that scenario.
Imagine that. That would just be
Fail maths.
Now, which is the next largest angle in the triangle ABC? Give a reason for your answer. I'd say the angle CAB. CAB?
Yeah.
Why?
It's facing, because 8's bigger than 6.
It's facing the next largest side. Facing the next largest side. Scale factor. This is important. Are we ready for this, guys? What does scale factor mean? What's the scale factor mean, guys? You make it 2.5 times bigger. When you scale factor stuff, do you change its shape? No, you just increase its length. So I'm going to increase the length of every one of these by 2.5. Is that alright? So I can do it two ways. I'll show you both ways of doing it. Okay? The first way I can do it is I can increase everything's length by 2.5. You happy enough with that? So that will become 15. That one there. 30. The other one there. 20. It told me that the scale factor is 2.5.
6, okay, times 4.
Make the length bigger, 2.5 every one. Josh, you told me that's 117.3 degrees, was it?
Yeah.
Anybody know how to get the area of a triangle? Half base by height will only work when you actually know one of the heights. Alright? Now, the other thing I want to beat home here is that it's only really easy when it's an isosceles triangle or an equilateral triangle. When it's an isosceles triangle, you can drop it straight down, and if that was a length of 20, it would cut into two tens, and you could actually find it out quite easy. For scalene triangles, you can't really do that. So you have another. So here are your following options. Option A is the area rule, which is S equals A plus B plus C all over 2. And then your area formula is the square root of S minus A, S minus B, S minus C. Anybody remember doing it that way? Yeah? Okay, shh, we do it that way. You can only, excuse me guys, you can only do it that way when you know all three sides, which we do. Can anybody tell me an easier, quicker way of doing this? Trigonometry methods? Not the cosine rule is not for area. Half AB sine C. So, a half AB sine C is this here. You have two sides, and you use the angle in between them. It's an SAS system. So, a half. What two should I use?
15 and 20.
Why should I not use 15 and 30? Don't know the angle in between them. You know the angle between two of them. Okay, and what do we get here? Anybody tell me? 0.5, which is a half. 15 times 20. Sine 117.3. 133.3. Every cool with that? Yeah. Now, I could have done this a different way. Okay, here's the other way I could have done it. I need to make you familiar with both though. I could have went back up to the original triangle and did exactly the same trick, except what? I'm not finding the area of the big triangle, I'm finding the area of the small one, the original. Okay? So I'm going to do a half AB sine C again. And I'm going to do a half 6 times 8 sine, what's it, 117.3? So 6 and 8 instead. 21.33. Lads, I thought it's 2.5 times the size. What happened there? I thought it had to be 2.5 times the size.
The area is squared.
Area is squared instead. So most of you will think to get this answer here, why don't you just get the area of the small one and multiply it by 2.5? The 2.5 refers to one-dimensional lengths. Area is two-dimensional, so you have to multiply by 2.5 squared. There's your 133.3 there. For those of you that don't understand it, simplify the problem. What you could do is you could say, if I have a square of length 2 and 2, what's the area of that square? 4. If I multiply it by a scale factor of 3, it turns into 6 and 6. Would you agree with that? The first one is 4. The second one has an area of, but 36 is 9 times bigger than 4. So that would mean its k squared gives you 9 times bigger. You had a question with the last thing I did?
Yeah, one of them's wrong.
Which one?
Because in the calculator you got 133 and there it's 113.
113, is it?
Yeah.
Okay, just give me a second. 6 multiplied by 2.5 is 15. 8 multiplied by 2.5 is 20. A half 15 times 20 sine 117.3. Ah. The first one was wrong. Is that right? So it's 133.3. Good eye. Now, that was that one done there. Find the area of the image. Okay, 2 different ways. They might ask me. They actually asked me a weird one here. Okay, it's actually explain what is meant by the incircle of a triangle, guys. What is meant by an incircle of a triangle? Huh?
Touches all 3 sides and then it's
So you actually have to explain what it means though. So it's the result of when you have a triangle, it's the circle that exists within a triangle such that the circle, each side of the triangle hits the circle in one position only. Okay, so each side of the triangle is a tangent to the circle. That is the incircle of a triangle. If I ask you what incenter means, it's the center of an incircle of a triangle, where the incircle is a circle that only gets hit once by each side of the triangle. Just explain what it is in your own terms. Then I ask you to do the construction. I'm assuming you've done your work on that, and you can draw your own constructions, okay? Now, how much time do I have left? 2 minutes. 5 minutes left. Okay, guys. I just want to show you how to start this one off. This one once again is in the sort of the really difficult range of question. All right. So you're looking at this and going, here's a random assortment of lines and circles I haven't got a clue about. But what I'm asked to do is I'm asked to prove that AKC is isosceles. What's the only way to prove that AKC is isosceles? What's the only way to do that? Anybody know? Either find the 2 lengths that are the same, or find 2 angles that are the same. Now it's going to be KCA, it's going to be this one and this one, but you wouldn't really know that at the time. KCA and AKC. I might actually measure them with my protractor as a guide to see which ones actually are exactly the same. Just as a little cheat to see which ones I should be aiming for. Now, here's what we're going to do. OB equals OD. What reason? OB equals OD? Huh? OB equals OD. Radii. Okay, everybody cool with that? I'll just keep marking them. I'll just keep ticking them as I do them. BDO equals OBD. BDO and OBD. BDO is that one there. OBD, that one there. What's the reason? It's an isosceles triangle, right? And that was 90 degrees. So that makes both of them 45. Done. Next you move on to AB equals AD. What does AB equal AD? It tells you. Okay? So now you know these two lengths are the same. After that, guys, what can you say then? If the two of them are the same, what does that mean then? Anybody know? That's the green one. The two of them are same. It means the two pink ones have to be the same as well, because they're about the same angle, okay? So that means that the angle ABD equals BDA, which is just a we don't know this value here, alpha, but we know that one there also has to be an alpha because they're equal to each other, and the other part was 45 degrees. So that gets you that far down the question, okay? I'm probably going to run out of time now. I'm out of time.